Welcome to the last PowerPoint lecture for Chapter 6, and here I will cover the conservation of mechanical energy. Follow along in Section 6.5 in your textbook. The total mechanical energy of a system or object does not change unless a non-conservative force does work on that object. In this case, the total mechanical energy is equal to the kinetic energy plus the potential energy. Generally, this will be the gravitational potential energy, but it also can be an elastic potential energy. Total mechanical energy will remain constant in a system as long as no non-conservative forces act on that system. In this case, we have a bobsled going down a nice icy luge and sliding down there. There's going to be no friction acting on this bobsled. It starts at the top with a speed of 0 meters per second. At this point, all the energy is in the form of potential energy or gravitational potential energy. As it moves down a little bit, it starts to gain some speed. That speed, or kinetic energy, comes from the transfer or loss of potential energy. Notice how as this bobsled throughout the entire system, the total energy does not change. The energy only merely changes forms from potential to kinetic. Well, we said that tension was a non-conservative force. In this case, it does no work. That is because the force is always perpendicular to the speed or velocity at all times. All it does is change the direction, but it does do no work in taking energy out of the system. Work causes a change in energy. If a non-conservative force does work, it will change the energy of a system. This means that it takes energy from the system. In the case of a rocket not going to the maximum height, the loss in potential energy is done by air resistance. The force acted along the displacement. If a car slows down after the engine stops, the loss in kinetic energy is due to friction. The force of friction acted in the direction of the motion. It is important to understand that these non-conservative forces need to do work for there to be a change in the energy of a system. Here are a couple of equations that show the total mechanical energy of a system. I did not take the time to go in to rewrite all of the potential energy equations as a U. Just understand that while the book does PE, the AP exam does a U sub G. We will tend to use U sub G for the rest of this class. Here is a dirt biker that jumps off a cliff and lands on another cliff further down. We will say that there are no non-conservative forces acting on it or that total mechanical energy is conserved. What I would like for you to do for your sample problem tonight is to solve for the final velocity of this dirt biker. The big hint here is that you really don't need to know the mass. It's not important to be able to solve for the final speed of the dirt biker. Set up the equation so that the total initial mechanical energy is equal to the total final mechanical energy. Please put your answer in online and have a good night.